I'm Jasma Balasubrameshwara from the Department of Computer Science and Technology, School of Engineering, Dayanand Sagar University. On behalf of Dayanand Sagar Institutions and Board for IT Education Standards, it is my honor to welcome our speaker, Shri Ashwin Rangan Sir, Senior Vice President for Engineering and Chief Innovation Officer, Internet Corporation for Assigning Names and Numbers, ICANN. I heartily welcome all the members, the deans, directors, faculty members, and students. I request Dr. Sanjay Chetnis sir, Chairman, Department of Computer Science and Engineering, Dayanand Sagar University, to please introduce Shri Ashwin Ranga sir to our participants.
Thank you, Dr. Jasma. We are really honored to introduce a very illustrious guest today, Shri Ashwin Rangan. I think in India we can call him by his full name without twisting tongue, Ashwini Kumar Venkataragavan, Ashwin Kumar Venkatarangan. Sorry, I did make a mistake. It was a long thing. So he obtained his bachelor's degree in mechanical engineering from UBC, Bangalore University in 1982, master's in industrial engineering and industrial management from National Institute of Industrial Engineering in 1984, certificate course in corporate directorship from UCLA Anderson School of Management in 2002, and completed course in cybersecurity, the intersection of policy and technology from Harvard Kennedy School in 2018, as well as the course in NACD CMU CERT in cybersecurity from Carnegie Mellon University in 2021. I mean, this shows what we mean by lifelong learning, right? I'm sure more than this, he has learned a lot in various things formally. He's currently working as SVP Engineering and Chief Information Officer at ICANN. Previously worked as member of board of GARND PAD, I don't know how it is pronounced, but member of the board of advisors of Smart Energy Water, advisory board member of Market Share, CIO of Edwards Life Sciences, advisory board member of Intake Green Corporation, strategic consultant, CIO of Bank of America, GM, that is production development, and CIO of Walmart Global, board member of PIVX Solutions, and advisor to University of California, Irvine. He was honored with Distinguished Alumnus Award 2015 by National Institute of Industrial Engineering in November 15. He has secured more than 3 decades of work experience in wide variety of portfolios by making significant contributions to each of the organizations where he has worked. So very grand career, sir. And I just noticed that when he was a student, he had excellent extracurricular activities. He was in fact a student leader in UEC. He was captain of Stage Arts Club of UEC. He also excelled in sports, softball, badminton, etc. So that kind of shows, I specifically mentioned this to our students, so that kind of shows the kind of foundation he made for his career. So thanks a lot, sir, again for being with us for this excellent topic. We are looking forward to it. So over to you, sir.
Thank you so much. I appreciate it, and I appreciate the opportunity to share some of my thoughts with you this evening in Los Angeles time, this morning in India time. I have a deck of about 22 slides. I'll go through them, and I make a request of the audience to either post your questions into the chat pod or hold your questions until we're done. I will answer your questions at the end. So with that as a request, I'm going to start. First and foremost, a big thank you to the Bytes team that put this together, Professor K.N.B. Murthy, Dr. Puttamadappa, Dr. A. Srinivas, Sri M.N. Vidyashankar, Srimati H.L. Jyoti, all of them were in touch with me off and on every once in a while. Dr. Jasma as well. Friends and family, Arvind Srinivas in particular, he is the one who made the introductions and made this happen for us. My many friends from Karnataka schools whom I shared the invitation with, some of them said that they would be in a position to join, and I also shared it with my family in the hope that some of them may be able to join if they're interested in these kind of topics. So let me start by framing the presentation. As educators, And as it was said earlier, I'm an advisor to the University of California, Irvine, especially in their School of Management and Computer Science. I work with their School of Management directly, and we pull people in from their computer science school as well, because we are interested in figuring out what digital transformation really means. So there is a Center for Digital Transformation in UC Irvine, which is led by one of the assistant deans of the School of Management. And I serve on a board to advise him and the school about how to transform what they offer. So I'm very interested in education and have been for quite a long time. I serve as a visiting professor every once in a while in local universities, UCLA, UCI, and USC. And when I'm up north in the Silicon Valley, also in UC Berkeley. We'll be talking about 8 different technologies, some of which are certain, as in they're already here and being used, and some of which are certain in the next 10 years, as in they're in their nascent stages, but are slowly but surely starting to gain traction. So the discussion framework will be looking at strategic possibilities and some industry use cases, and then what courses could be offered and what free resources are available to learn more so that these become real and not just theoretical. Why this topic? Why now? If you think about educators, every educator, particularly those that are responsible for administration, have a duty of care. It requires the educators to remain continuously diligent in staying informed and abreast of new technologies and developments. That is part and parcel of what they are. They need to be looking forward because their product is both research on the one side and students on the other. Their research has to be about what is likely to happen in the future, and their students have to be prepared so that they're future-proofed and are actually capable of not only understanding the future, but ideally in shaping the future. The world of IT, as we all know, is rapidly changing. Being a part of ICANN, I can lay claim to the fact that we are architects of change as much as we are at the receiving end of change. But the net impact of the rapidity of change is that the half-life of information that is imparted in classrooms is now less than 10 years. In other words, 50% of the stuff that you learn today and graduate with in 10 years' time will be useless because it'll be supplanted by new things that are happening in information technology. Now, regardless, Karnataka as a state has a long legacy of breeding brilliant engineers. As it was mentioned earlier, I'm a product of UBC, which was founded by Sir M. Visvesvaraya and is named after him. He left a legacy that is second to none on a global basis, not just a national or a statewide basis. He's renowned around the world as a brilliant engineer. And that's a legacy that we as Karnataka people have the right to carry forward. We're flag bearers of that legacy that he's given us. And Bangalore, as a metropolis, we are all aware, has grown into becoming India's Silicon Valley. So what we'll be talking about today are the seeds. If they're laid properly and they are harnessed well, they will become sturdy trees in the next 10 to 20 years' time. But we have to start now. There is a gestation period that is associated with any seeds. So it's really important that we start early and grow them. Now, the 8 technologies that I'm going to talk about are quite a collection. We'll talk about robotic process automation, industrial robotics with IoT in the background, sensors in the background, wearable monitors in the background. These are already here. With 100% certainty, there are some top-line drivers. Artificial intelligence, machine learning is a part of artificial intelligence. 3D printing, quantum computing, these are all here. These are not speculative anymore. It's only a question of how fast as opposed to whether. With 100% certainty, there are other business environment enablers that are happening. 5G cellular, we'll talk about that. They will provide ultra-fast internet speeds. It's stunning to experience 5G. I happen to live in an area where I have access to 5G when I step out into my backyard, and it's comparable to what I have with hard line cable in my home, which gives me about 500 megabits per second. So whether I'm on the cable at home or I'm in the backyard, I get the same 500 megabits per second. It's stunning the kind of things that you can do when you have experience of 5G. Less certain, but advancing at the same time as we're speaking, are Android robots, which is somewhat of a variant, a buildup of number 2, which is industrial robots. And digital currency, also known as blockchain-based cybercurrency, we read a lot about it, but it has not yet become fiat currency in any country in the world yet. It's not a main street accepted currency, but it is starting to find its way to Main Street in different shapes and forms. These are the 8 technologies. Now, I want to dwell a little bit on these 8 technologies, because what's interesting when I look at these 8 technologies is that none of them is specifically computer science alone. Many of them are what I would call as hyphenated sciences. Some require mechanical engineering knowledge. Some require electrical engineering knowledge. Some require communications engineering knowledge. But they all require an understanding of how computers work and how computers can be applied in different ways to different things. If you think of number 8, for example, digital currency, you have to have a fundamental understanding of cryptography, which is a specialized science inside of information technology and computer science, no doubt. But equally, you need to have a good understanding of economics, because you can't create currency if you don't understand how the economy works. So these are hyphenated sciences where breadth of knowledge is as important as depth of knowledge. That's a remarkable difference between what we saw 30 years ago when someone chose IT as the field of knowledge that they wanted to pursue, and what they need to now do in order to pursue IT as their field of application. Whereas 30 years ago, it was a more purely defined science. In 30 years' time, IT will be integrated into everything, so much so that it will be subsumed, very much like electrical technology is today. Today, we as lay consumers of electrical technology do not have to think about where is the power generation plant, what is the power distribution system. All we need to think about is where is the plug point and where is the switch. Similarly, IT will become ubiquitous, and because it will become ubiquitous, we need to understand from now where the application areas are and start to impart that knowledge to students so that they become better prepared on how to leverage IT in the fields that are becoming more and more common. So first and foremost, let me talk about robotic process automation. The world is full of computer systems that don't talk to each other. And robotic process automation is one of the ways in which people are making many different things talk to one another. These are what are known as software bots or software robots. They're already here, particularly in bureaucratic, system-based organizations. The banking world is particularly known for this. I served briefly with the Bank of America as a strategy advisor and a CIO for the retail banking division. And the portfolio of systems in the bank was close to 10,000 systems. 10,000 systems with everything from COBOL all the way to the latest and greatest technologies, including AngularJS. So it's very difficult for those kind of environments to keep up with technology. They have to rely on legacy technologies at the same time as leverage new technologies. And when they do that, robotic process automation comes to their aid in helping them to scrape information from one system and paste it into another almost in real time so that transaction flows are uninterrupted. Very typical, for instance, is web-based front-end systems in banks which rely on back-end systems, depository systems that take deposits and make sure that the account balances are kept in tune with whatever is happening, those tend to be legacy systems. The front end with which we interact with the bank, with online banking, is connected to the rear systems, which are on legacies. And very often you see robotic process automation in between those two. At a minimum, subjects that would be required would be computer programming basics, basics of secure coding, because if you think about it, when there are any two systems and there is an interfacing system that's built to scrape information from one and put it into the other, that interfacing system becomes a vulnerability unless it is coded to the highest of security concerns, particularly if there is anything that is privacy oriented in the two systems that are interacting with one another. A third subject that I would recommend highly is APIs, or application programming interfaces. And along with that, the underlying technologies of SOA, or systems-oriented architecture, and RESTful programming, etc. Free, inexpensive resources are available to learn about these. UiPath offers an academy online for free. UiPath is a provider of one of these systems. They are a vendor of software bot systems. Udemy, which is an online learning tutorial kind of a portal, offers a learning course in this for $20, $20 US. So this is one example of a technology that is here and already in wide use. A second example is high-impacted industrial robots. You know, the pandemic, many countries went into a lockdown. And what that forced is an incredible increase in e-commerce. Many countries started to realize that their entire population was relying on e-commerce purchase and deliveries just to keep the households running, for fear that stepping outside the house could lead to a potential exposure to infection. What it did from an e-commerce perspective is put a tremendous amount of pressure on the e-commerce fulfillment centers. Now, if you think of fulfillment centers, they do three things, and only three things. Based on the order that's been placed online, they pick, they pack, and they ship. Each of those, if you go back even 10 years, used to be a manual, labor-intensive task. Picking the right thing from the right place, the right shelf in the right aisle. Packing, as in putting it into a box with the right kind of packing so that it wouldn't get damaged in transit. And shipping, which is the physical act of putting it on a truck and having the truck move from the distribution fulfillment center to the intended destination. But with the pandemic, we saw a tremendous acceleration of industrial robots. What you see on the screen to the left of the aisles are industrial robots that have been programmed to pick and pack. They slap a label on so that they go all the way to the back end of a truck, so that the loader on the truck is able to pick up boxes and put them into the truck, and off it goes from a shipping perspective. Now, to make all of that happen takes incredible amounts of programming, because each of these industrial robots that you see here is an autonomous vehicle that has to know where to go, what to pick, which box to put it in, and how not to collide with anything in the process of picking and packing. So these are like mini cars without a human driver. They have to sense their surrounding and make sure that they're not on a collision course with anything, and yet fulfill the order list that they've been asked to pick and pack. So the other thing that they bring with them, industrial robots, is that they're uncomplaining workers. They will work 7/24, 365, whereas your average labor will typically work a shift of 8 hours with a couple of breaks in between. Relatively speaking, therefore, when you deploy a robot, you have 3 times the potential productivity. There is a modest to low operating expense But there is a high upfront capital expense to get yourself equipped with this. They're highly redundant and they're very reliable. There are already examples of this, not only in the distribution business that I mentioned, but in the manufacturing business as well. At a point in time in my life, I was part of one of the founding teams that founded a semiconductor manufacturing company. Semiconductor manufacturing today is almost 100% computerized. The manufacturing process back in the day had 184 steps, 175 of which were in extremely toxic chemical environments. Etching, which is the act of using extreme acids to create circuits on silicon boards, is done completely without any human intervention. Stepping, which is the act of putting new lines of connectivity onto that base trait, is done completely automatically, and so on and so forth. That is completely automated so that it's the material handling system and the programming of which is becoming important. It's not the manufacturing process itself. Increasingly, with auto manufacturing, that's becoming the case, particularly as we go towards electric vehicles. Tesla, as an example, is about 80% manufactured by robots, and only 20% of it is done with human beings. So what do we need to teach our children and youngsters when they go to the university now? Well, machine learning, computer vision, robotics fundamentals. There are many resources available already for this. Cut Robot Academy is available online, QUT. You can see that. You can pick any one of these resources and see for yourself. MIT has an open courseware course that offers anything you want to know about robots that they offer in class. Stanford offers an introduction to robotics. Coursera has a control course on robotics, and edX has a robot control course offered as well. So these are, again, widely available, highly subscribed. In fact, if you try to get onto them, sometimes you get booted out saying that the quorum has already been met. It's that popular. Artificial intelligence, I said that it's 100% certainty because it's already here. It's everywhere. It's embedded in so many things. It's incredible, but we don't really think about it in that fashion. I'll give you a very simple example. When you look at your email inbox, not every email that you get actually gets to your inbox. In fact, the vast majority of emails that come to your environment, however you define your environment, let's say it's .edu and you're an educational institution, less than 10% of the email that comes to the .edu domain actually comes through. And of that 10% or so that does make it into your domain, a high degree of examination is done before emails are delivered into your inbox, with rules that get put in place, typically by your system admins. Every email system in the world has these system admin tools that are available, and these tools are actually AI tools. They have enough intelligence to figure out what's spam for the most part and what's a legitimate email, and to filter only the legit emails and have them go through. There are other systems that are in use today. You think about databases. Databases accumulate data at a phenomenal rate. Think about Flipkart as an example in India, an e-tailer in India as an example of e-tailing. They have a content repository which makes available all the things that they're willing to sell to you. They offer up to you. Those things that they offer up are continuously being ingested. Flipkart became acquired as a company, a subsidiary of Walmart. Walmart has a phenomenally large catalog, and they're continuously trying to figure out what to offer in which geography. That updating of content is typically driven by software, not by human beings. You have humans looking at what the software is doing, but the software is doing most of the heavy lifting and moving things from a content catalog into the database, and then there is further fine-tuning of it by offering the same thing in multiple different zip codes or pin codes and testing them out to see which one is moving where. That's yet another example. Language auto-translation. India is a wonderful example for this, where every region in India has a different scripted language. It's quite different in that regard from Europe, which comes close in terms of the diversity of languages, but all languages there are more or less scripted on the Latin script. Whereas in India, practically every language has its own script. Imagine the difficulty if you have to offer e-commerce in every local language. That becomes possible by using an AI engine. And lastly, the example that I cite here is mining customer and sales data for hidden patterns. This is a well-known problem. When you have a lot of order data from a lot of customers, finding what is moving and what is moving fast is one of the hardest problems to solve unless you have the ability to pull together all of the sales data or all of the order data and looking at it in the aggregate and seeing whether there is a trend line flat and to the right or up and to the right or down and to the right. That's the only way in which that can be done. That's, again, programmed into systems, and that system therefore starts to obey certain intelligence rules, and therefore you have the artificial intelligence. But these are relatively simple examples. This gets more and more complex when you look at something like Google's artificial intelligence engine, and I did about 6 or 7 months back. They had 27 layers. So all I talked about is one layer. Imagine that multiplied 26 more times, where there is a derivative on top of a derivative on top of a derivative, and so on and so forth. So if you think about it in calculus terms, this is like not dy by dx or d squared y by dx squared. This is d to the 27y by dx to the 27. So it's remarkable, the level of granularity and the level of correlations that they're looking for. So subjects, neural nets are important. Computer programming is obviously important. Advanced algorithmic development, cognitive science, these are all very important fields to study and master in order to become good at artificial intelligence. And there are others. I'll come to those in a second. There are plenty of resources available. Google makes available machine learning online. Andrew Ng offers a course in Coursera. He is one of the renowned experts in this field. IBM offers a starter kit. You can literally download the starter kit and learn in 6 weeks what it is to become better at AI. Not an expert, but better at AI. Linear algebra, MIT offers this online, and it also offers an online course in AI. That should be an O, not a P. If I had AI, it would have corrected that for me. The fourth one that I want to talk about is 3D printing. Pardon me. When you look at the picture here, these are two jet engines. The jet engine on the left is something that was recovered from the Apollo 8. The jet engine on the right is one of the Falcon engines that SpaceX uses. When you look at the left and the right, you can literally see a difference between the two. It's, by the way, the engine on the right is more powerful than the engine on the left. And when I scaled it to size so that it would be comparable. So the one on the right is more powerful than the one on the left. And the one on the right is substantially simpler than the one on the left. The difference is that the engine on the left is what is known as subtractive engineering, whereas the one on the right is additive engineering. So what do I mean by subtractive engineering? Subtractive engineering is where you have an enormous bill of materials, and every single component of that bill of material adds itself into the making of the final good. In additive engineering, the bill of material is extremely simple, and layer upon layer of metal is literally printed so that the functionality that is desired is delivered by what gets done by the additive manufacturing technique of adding material one layer at a time. This is becoming very common. in two different areas. One is in undifferentiated things. So, for instance, bathroom tiles, ceramics are now printed. And because they're printed, the variety is endless. It's only the imagination of the designer that determines how many different kinds of bathroom fixtures and ceramics can be made available. Colors, shapes, sizes, any one of these are all just parameters from a programming perspective. That's at the one end of the spectrum. The other end is extremely complex bills of material. I cited the example of the SpaceX engine. They started out by saying, how can we get ourselves the same capability, if not superior, to what was used by the Apollo mission? And they landed up with the Falcon engines, which are incredibly simple by comparison. They've reduced the bills of material by a factor of 100, as in, if there were 1 million parts, they've taken it down to 10,000 parts. That's just an example of how simple it can become with additive engineering. It also becomes easy for swift prototyping. Imagine if you were able to render something into a drawing. You can feed the drawing into a 3D printer, and you can feed it the raw stock. It comes like a wire that can be molten. It melts, and then it can be sort of layered one after the other to create whatever object you're looking for. You can create whatever object in whatever shape and size you need and swiftly prototype it. In a day or two, you have a prototype, a sample, or a few. And then from there, you start asking questions of the customer base, whether this is what they want or something a little bit different, whatever it may be. We're seeing this in toys, with medical implants, entire engines. With COVID-19, we saw an incredible explosion of additive manufacturing with PPE, the equipment that's used to keep people safe, particularly in hospital settings. But to become expert at this, it's not enough to just be a programmer. You have to also have a good knowledge of solid mechanics, strength of materials, drafting, material science. There are lots of courses available online for free, things like beginners, instructables, 3D printing from LinkedIn Learning. Skillshare offers classes. Udemy has an entire printing, I think they have a certificate course in this. The fifth thing that I would talk about is quantum computing. On the right, you see a picture of Sundar Pichai standing next to the quantum computer that Google has created. This is in Santa Barbara, just up the street from where I live. This is 100% certain. The only question is, when will it become mainstream? We're already starting to see applications of this in many different places, but these are extraordinarily expensive machines. Like most machines, when they first get created, they're extraordinarily expensive. But what we're likely to see is quantum as a service. They're extremely good already at singular computing tasks, as in you give it a well-defined problem and it's able to crack through the problem with no problem at all. Ultra-fast modeling, ultra-fast simulation, ultra-fast code breaking, these are all things that it's able to do already. Not a great deal of specialized programming, but with a great understanding of things like exponents, vector algebra, sine wave functions, probabilities, stochastic processes. These are all things that you need in addition to just programming in order to become good, leave alone an expert at quantum computing. Once again, many places to look for resources. MIT has an XPro course that specializes in quantum computing. CERN, which is responsible for the Large Hadron Collider in Europe, offers a course in this. Coursera has them, edX has them. There are vendors like Google and Atos and D-Wave in Canada, which are making available their computers as a service at a fairly significant cost. But for companies like banks, it is easy for them to use these for cracking problems that they have in portfolio risk assessment, for example. Or when you think about genomics and proteomics, which has come to the forefront as a result of vaccines that have been developed to combat COVID. This has come to the forefront as well. They are very gnarly problems, genomics and proteomics problems. Protein folding is one of the hardest things to simulate, but with quantum computing, it's becoming a problem that we can take on. Stress fracture in materials, very, very hard problem in mechanical engineering, can be done with quantum computing. 5G cellular technology. 5G means a lot of different things to different people. I tried to capture the various dimensions that go hand in hand with 5G. It's high throughput, easy service deployment, high mobility, connecting devices in the zillions, as in billions already. There are up to 25 billion units that are connected to the internet, as we know of it right now. Highly energy efficient. They can handle very high data volumes with low latency. Those are all the attributes of 5G. I'm not talking about 5G, the core technology, but the attributes with which it presents itself. Huawei has been in the news for a while now because of trade wars. Ericsson, Nokia, and Samsung are all leaders in 5G technology on a global basis. And this is a certainty. It's just a matter of when will it become available in your geography, so to speak. In the next 3 years, the largest providers in the US have made commitments to roll out 5G across the nation. It's an enabling technology. In other words, it makes available a base fabric that can be leveraged for doing many other things. Industrial sensors and actuators with remote management, in other words, these are control systems, can become ubiquitous with this. We see the early signs of it already when we use things like a Nest thermostat at home to regulate the temperature in our household, as an example. It does things that are visible instantaneously on my cell phone, no matter where in the world I am. There are cameras around our property that can be turned on and off. Lights can be turned on and off in the house. These are all capabilities that we can leverage at extremely high speed. Or if I want to watch a movie that I've stored on my server at home, but I happen to be in, I don't know, Japan, I can download that movie at an alarmingly high speed. I can download an entire movie in like 3 minutes. Autonomous vehicles. I talked about Tesla earlier. Tesla has the capability to self-drive. If every other car on the road were also like a Tesla, the probability of accidents is virtually negated, not just reduced, but it just disappears. Imagine how safe you would feel if the car is making sure that you're not involved in an accident. Subjects, electronics and communications, absolutely necessary hand in hand with computing and programming. Microwave engineering and antennas, because this is the way these things tell one another what's going on. They sense what's going on around them, and they inform one another in a cluster what's going on using microwaves and antennae. Network security and protocols, because you want to be sure that things are not going awry. If something is meant as a packet for X, it shouldn't go to Y. Or if it's meant for Y, it shouldn't go to Z, and so on and so forth. I've listed some of the resources that are available so that you can just undertake free training. The last one, by the way, free 5G training, you can look that up on Google and it'll show you exactly what's available. That's the name of a course, actually. 7 and 8 are more speculative. This is an android robot. By that, I mean it is more human-like than an industrial robot, which looks like a crate with 4 wheels on it. There are some places where this is becoming more visible. I will cite Japan as an example. It's an early example. Silicon Valley is not a good example because Silicon Valley likes to try anything and everything. But Japan is a good example where this is already in the consumer market as a companion robot. Japan has a very unique problem in that the demography of their aging is favoring the older population. Their replacement population is not there. It's just a hollow. In other words, there are many old people with not a lot of people to take care of them. Loneliness is a big problem in Japan for the elderly. And these are companion robots that are able to serve as a concierge. They're just there. You can converse with them. They can do some menial tasks around the household. They can assist you, so on and so forth. It's early iterations. Whether it'll catch the mass market remains to be seen. But some interesting things are starting to happen when we are into this android robotics. Ethics becomes very important. Isaac Asimov wrote a book some time back, 40, 50 years ago, and he came up with 3 laws of robotics. If you read them, they're still as valid today as they were when he first coined them. But that's just the beginning. We need more ethics because these robots will do exactly what the program that's written for them will tell them to do. They don't know the difference between good and bad, right and wrong, ethical and unethical. So the programmer has to have the ethics and the fabric to make sure that the code that gets written and is reviewed is not crossing any tripwires, so that we are doing things that are permissible by society and not going to the wrong side of it, legally or otherwise. It's important to read about mechanical robots and electrical control theory. Many things are again available for free. Cybernetic Society is a society that specializes in this and nothing else. They offer courses. University of Reading offers a Future Learn. It's an entire certificate program in robotics. OpenEDU has a robotics course. Coursera has a robotics course. And on the left side, you see some names: Canvas, Piaggio, Picnic, Anybots. These are all examples of companies that are in the Android robotics business today. And lastly, digital money. I handicap it at a 30% still, not higher than that, because there's a lot of talk, but not a lot of action here. We're seeing some action in some places, but not pervasive action. And it's not becoming Main Street action. It's in niches, in pockets, here and there. But there is a case to be made. There are some currencies in the world where the national fiat currency, in India, the fiat currency is the Indian rupee. In the US, the fiat currency is the US dollar. But in certain countries, the national fiat currency is not very trustworthy. They have hyperinflation. Zimbabwe was in the news for many years because of runaway inflation. There are several South American countries that have experienced runaway inflation. So the hyperinflation problem is a very difficult problem. There, you need a currency value holder. And these are examples of new currencies that hold value if they're properly treated. There are examples of this. Of course, Bitcoin has been in the news for a while. And if you look at Bitcoin's own value, it has fluctuated randomly, gone up and down multiple times. I don't know what it's trading at, but it was in the tens of thousands of dollars per Bitcoin. Ethereum is a second example. Facebook has Libra. WhatsApp has said that in June, they'll start to offer something that could be available as early as July of this year as a currency. But to become good at this, not only do you need to know about money, monetary theory, economics, but you also have to know cryptography basics, because these are currencies that are based on cryptography. Cryptocurrencies is another word for them, and they use what's known as an open ledger. So to understand what's an open ledger, you have to understand what's a regular ledger, and that says you need to know bookkeeping. And then you need to understand what's known as blockchain fundamentals, which is a very specialized construct inside of computer science. Probably one of the most fascinating constructs inside of computer science that I've studied, certainly in the last 10 years. These are again available as resources for free on the internet. Blockchain Theory 101 is a course. Enterprise Blockchain Fundamentals is offered as a course. Coursera offers courses. There is a blockchain course offered at UC Berkeley on Ethereum, specifically on Ethereum. It's available online. Pluralsight offers a brilliant course in blockchains. So these are all, again, free resources that you can look at. So I asked myself, all right, you've been thinking about this. Who else has been thinking about it? And fortunately for me, this came out in January, middle of January this year. The Economist weighed in on many of these technologies, not all of them, but many of them. And this is the way they handicapped it. So as you can see, just about every one of them is projected to be over the 50% mark within the next 5 years. So blockchains is at the lowest end of the list that you see here. And as you probably know, The Economist as a magazine tends to be a very conservative estimator of things. So even in their conservative estimate, these things will become mainstream, as in beyond the 50% point within the next 5 years. One possibility that I was thinking of, because this was to help frame coursework is to think of this perhaps as an advanced computing course, a master's degree program perhaps, and offer it over an 8-semester period with a couple of projects thrown in alongside of it. One industry project in year one and the second industry project in year two. This is just one way of thinking about it. But having something like this, if I were on the hiring end of the spectrum and I found candidates who came in not just with programming skills, but could show me that they had coursework in their background and industry experience on top of the coursework, they would become very interesting candidates, and I would consider them very favorably from a hiring process. So with that said, I'm going to revert back the control to the conveners, and I'm happy to answer any questions. Thank you so much.
Thank you so much, sir. I request Dr. Sanjay Chitnis, sir, Chairman, Department of Computer Science and Engineering, to please moderate the question and answer session.
Yeah, thank you, sir. Actually, there are a lot of questions coming up in the chat box. I'll read for you. So first question is from Srinivas. When we talked about the hyphenated sciences, what is the depth to which students need to study these cross-domain courses?
That's a very good question. It's hard to become both an electrical engineer and a computer science graduate at the same time. But I think 3 to 4 electives is what I would consider to be a minimum requirement to cross-fertilize from one science to another science. So for instance, if you think of 3D printing, I was talking about 3 or 4 courses there, the strength of materials, material science, 2 courses that are unlikely to be offered to someone in computer science ordinarily. But those would be an absolute minimum requirement in order to get into 3D printing, because that's what will be getting used in order for you to become good at understanding how the programming that you're doing is actually impacting the goods that are being produced by the 3D printing methodology.
Next question is from a student, Arsal Imtiaz. Sir, is cognitive science as used today as the other domains of AI, such as computational linguistics, vision, etc.? He probably wants to know, is it like other domains?
It is similar. Cognitive science is a little tougher, actually, because the underpinnings of cognitive science come more from psychology than it does from a science per se. So it is in and as of itself a hyphenated science to start with. So understanding that is tougher, but it's required, I believe, as we move forward, particularly if androids are in our future. Industrial androids are in our future without a question, but they require less of that than if we're talking about android robots. We definitely need that more. Ethics and that, to me, are the fundamentals.
Thank you, sir. Yeah. Next question is from Pratik Ashok. Sir, how can quantum cryptography be implemented compared to quantum brute forcing? And how will it be able to more effective in cyber defense when compared to offensive security?
It's got like 9 layers of questions in that. Look, quantum cryptography is worthy of a lecture in and as of itself. Today's cryptography is based on a specific algorithm that is leveraged globally by every provider. And that particular algorithm, using conventional computing, cannot be broken. It takes years and years. If it's been hashed and salted, it's in SHA-2 and it's in 256 or 512 bits encryption. It's very hard to break it in anything less than 50, 100, 200 years. But with quantum computing, that can be broken. It can be broken in seconds. And therefore, when quantum computing is used offensively, the cryptography that is currently used becomes vulnerable. That is the real issue here. That's the forcing function that you're talking about. But it really requires a much more detailed answer than I gave you. In the interest of time, I'm just going to curtail it to that, with your permission. If you want to talk to me about it in parallel later, feel free to, please.
Yeah, thank you, sir. And one good thing you have done is you have given pointers for self-study, all these courses. So I think Pratik can go and start using those links.
Absolutely.
Thank you, sir. Yeah. Next question is again from Marcel Imtiaz. Sir, can you speak about the codependence of the mentioned domains? For example, how AI, 5G, and robotics are combined in Tesla self-driving car solutions?
Yeah, well, AI, 5G, and robotics. AI, if you think, one way of thinking about AI is as machines that have been imparted human knowledge. That really is one way of interpreting the terminology AI, right? So it's layers of programming that are imparting rules based codes with which machines behave. Tesla has that in spades. 5G, it doesn't necessarily leverage 5G. It leverages anything that it can lay its hands on. If it's 2G, it'll use 2G, or 3G actually. It uses 3G, it uses 4G. If it gets 5G, it'll use 5G. Or if it has a Wi Fi network that you've enabled inside the car, it'll use that. It'll use any means available to keep connected and stay connected. So it comes together in that fashion, as in it gets packaged. Whatever technologies are available inside the car get packaged, and the experience in the car is the result of that packaging. So when I'm driving my Tesla, it feels like it knows a lot more than I do. It warns me before I'm even aware of danger. It brakes before I'm aware that I should be braking at a given speed. It does those things because it is autonomous. That's the whole point of autonomy. It can make decisions. I just need to trust it to make better decisions than I'm capable of.
Yeah, thank you, sir. Next question again from Pratik Ashok. Sir, how much programming is required for a network security engineer?
Networking security it's a specialized field for two reasons. One is network coding is different from regular coding because there is a lot of routing involved in network coding. And security coding is different from other coding because it's a particular mindset with which you approach coding. It's not the normal mindset. A security coder approaches code very differently. He thinks like a hacker, but he wears a white hat, so to speak. So when you want to be a network security engineer and you want to be in the programming end of that, you need to combine programming with networking technology and security thought processes. So I would think about those three courses independently first, and then think about where the intersection points are and start to become deliberately a combining agent. Think of where they should be touching each other. The better you become at thinking along those lines, the more likely it is that you become a really good network security coding person.
Next question again from Marcel. Sir, e-commerce company Flipkart, that is in India, has started accepting Bitcoin as a payment option. So how would it affect the Indian economy as the value of Bitcoin is more susceptible for increase decrease compared to Indian rupee? And how can power electronics under energy systems be considered as a ninth emerging domain? The work currently done in the EV sector seems impressive. So he's also worried about powering EV as well as cryptocurrency probably.
Okay. Well, let's talk about cryptocurrency first.
Both, yeah.
The Bitcoin value is varying vastly, and therefore it is exhibiting some of the tendencies that fiat currencies in some not so advanced economies show, which is high variability and fluctuation in value. Which means that if you pay for a purchase with cryptocurrency in Flipkart today, let's say you pay $1, but the value that is associated with that Bitcoin dollar now goes up tomorrow by 50%, let's say. You will have what is known as buyer's remorse because you would have paid 50% more before your order was fulfilled. That's the impact of cryptocurrency unless it's stable and has a peg. Today, cryptocurrencies do not have a peg to any fiat currency, so they free float. They're like a stock more so than they are a currency. So if you buy something with stock, you have the same problem as you do with buying something with cryptocurrency. Stocks can go up and down in value. So if you say, I gave one share of Reliance in exchange for something, and the price of the Reliance share goes up tomorrow, then you paid more relatively tomorrow by tomorrow's standard than you should have, and you feel the remorse of having paid more. That's the problem there. Now, your ninth sector in Brazil with EV problem, I don't know the details, so I can't answer that question. I don't know the Brazilian EV sector well enough to comment. I'm sorry.
Yeah. Next question is from Pratik Ashok. So is it more beneficial to be a jack of all trades or a master at one? So with respect to cybersecurity, his question is cybersecurity.
I think cybersecurity is one of these areas where you have to start out by being a jack of many trades. You can't start out by saying, I want to be a cybersecurity person, because cybersecurity it's a substrate problem in that it is equally impacting on anything that has to do with computer coding, right? So you have to know a lot of different fields, but not at a great depth. You have to have at least a superficial knowledge about what's going on with many different kinds of systems. And then if you say, look, I have this natural tendency to think like a hacker. And I'll tell you, if you think like a hacker, you're thinking like a hacker. There are many, many people whom I met in the course of my career who are natural hackers. They just chose to be on the right side of the law. And I'm privileged to know many of them. They are really good at what they do, but they're really good because they understand a lot about different kinds of systems. So I would first argue that you should learn many different kinds of things, then commit yourself to cybersecurity and coding practices in cybersecurity to be a good white hat. That way, your value will be exponentially more appreciated by a hiring person on the other side.
Next question is from Dr. Srinivas, our Dean, sir. Sir, your views on over-specialization during undergraduate studies?
I think during undergraduate, it's a little too early, in my opinion, to over-specialize. Particularly in a field that is advancing as rapidly as IT is right now. I think I would delay that point of specialization as much as I can, perhaps even to the very last semester if the need be, because you have two different problems. You have a field of study that's rapidly progressing, and you have relative youngsters who don't really understand the world yet. They're not fully mature. I mean, they're not fully baked, right? I mean, somebody is 21 years of age. To ask them to figure out what specialization makes the most sense to them is a little bit of a stretch. So I think delaying that to the last possible moment, if not into the master's area, is probably a better thing to offer from an educator's perspective.
Thank you, sir. There is a question from Nachiket's. Is a supplementary question to Arcel's question. How do you think cryptocurrency would affect developing countries like India with informal markets where even digital currency isn't always accepted?
Again, a good question. Look, cryptocurrency, that's one of the reasons why I'm giving it 30% probability of success. The number of unanswered questions with cryptocurrency exceeds the answered questions by a factor of 10 right now. So in other words, more questions than answers are available with cryptocurrency. The leading banks of the world are keeping a close eye on it. JP Morgan Chase is probably the farthest along, where their chairman and CEO committed to having a fairly significant investment in cryptocurrency 3 years ago. He said that he would make $1 billion investment in cryptocurrency, and he has lived up to his words, and they have invested quite extensively in cryptocurrency. But the problem is that all of the things that are being tried out with cryptocurrency also hide the transactor. The identity of the transaction and the transactor are hidden for the most part, particularly if it's an open domain cryptocurrency like Bitcoin. You don't know who is at either end of the transaction, which is in one way perfect, but in another way, it leads to nefarious activities. That's one of the reasons why Mt. Gox blew up. That's one of the reasons why Silk Road blew up in the early days. That's one of the reasons why the Bitcoin blockchain, which was never supposed to fork, actually forked. So there are a lot of questions about cryptocurrency still that are unanswered. And until they get fully answered in terms that are easy to understand, because think about it, you're trying to offer cryptocurrency as a currency alternative to a banker who's perhaps one of the most conservative people when it comes to finances. While the allure of technology may be high, the utility value that the technology is capable of delivering seems to be laden with risk. So, where is the upside from a banker's perspective to buy into this?
Thank you, sir. Next question is from Gagana. How do you go about being a recognized expert in any chosen field in the quickest possible way? It's a very generic way.
Oh, you want quick as well.
Expert, yeah, recognized expert.
Expertise takes time, I'm sorry to say. That's one of the problems with wanting to be an expert, right? You have to either be a researcher and have a track record of publications, or you have to be a practitioner and have a track record of using technologies successfully in multiple places in such a way that other people recognize your expertise and are actually willing to use you as a technical expert in determining whether they should do something in that same field or not. Establishing your credentials in that regard takes time. So, quick and expert don't go hand in hand.
Next question is from Pratik again. I've not understood it, but probably I'll just read out as it is. Sir, wouldn't implementing blockchain to any third-party service like Uber makes the use of these platforms more efficient, but making this service provider obsolete because of decentralization?
Not necessarily, Pratik. The distributed ledger technology, no doubt, makes the ledger itself visible at every node in the supply chain. But it doesn't necessarily make the offer obsolete from a core offering perspective. It's an enabler, it's not a replacement. The transactional details are available at multiple nodes in the supply chain, but the value proposition, if it is strong, can continue to have a hold, particularly if the intellectual property can be actually safeguarded in the first place.
Next question is from myself. Quantum computing has a major technical bottleneck due to noise. So is it likely to be overcome soon, or is it going to be a risk?
Well, it's really a case of how many qubits are we talking about and what the capabilities are at that qubit level. As recently as 3 years ago, a 4-qubit machine was considered to be cutting edge. We're now talking about 200 qubits as being available. D-Wave offers systems that have 200 qubits capability, and some of them were leveraged in the formulation of alternative hypotheses in fighting the COVID crisis. So the advances are rapid. Noise is continuing to be an issue, but not an unsolvable problem. I think people are finding ways in which to solve it, and we will continue to see advances in that regard.
Thank you, sir. Next question from Sundaresh BS. Low code, no code is expected to democratize programming. Your views on its impact on software engineers?
Low code, no code has been around as the promise of programming for as long as I remember. It was first generation, second generation, up to fifth and sixth and seventh generation programming languages, each one of which said that it'll become low code to no code. But the reality is that even at these levels of programming, there is a need to know how to program and program well. I have seen more bad programmers than good programmers as I look back through my career. So learning how to program and program well, regardless of the level at which these programs are available, is a very important consideration. And while I have seen low code, I have not yet seen no code. Because if someone says this is a completely configurable system, the configuration capability that the system offers for no code is backed by a system that has incredibly large amounts of coding. So the question is, are you configuring or are you writing the program that is configurable? If it is the former, as in you're just configuring, it's no code. But if it's the latter and you're writing the configurable system in the first place, you need to know programming really well.
Yeah, I think questions are over here, but one question from my side, probably last question. So do you think there should be more multidisciplinary courses at undergraduate level, that is going across multiple streams of engineering?
You know, we debate about this in UCI, and I believe so. I'm a very strong proponent of hyphenated sciences. I believe that we have over specialized these fields with a thinking that is classical. When you think back 50, 60, 70 years back, with the fundamentals of engineering being the only constant, the divergence from one field to another became clear early on. You could say that civil engineers needed different kind of understanding compared with computer engineers within the first 3 semesters, perhaps. Maybe in the fourth semester, you went completely apart, your divergent ways. Whereas today, I think, particularly in the use of computers, the pervasiveness of computing is getting infused earlier into systems, and design thinking is becoming more necessary earlier in more systems than ever before. And when I use the word system here, I'm thinking about it not in computer system terms, but general terms. As in, there is an input, there's a process, there is an output, there is a system there. So using that definition of a system, design thinking of the system is becoming important earlier on, and the expression of design thinking with computerized tools is becoming important earlier on. So I would argue that these hyphenated thinking methods need to be introduced much earlier and should hold through and through, not with the desire of specialization, but with the desire of deeper understanding, so that the utility value to the industry that eventually employs the product of universities is actually perceived to be higher and is delivering that value. Because industry doesn't have the time, we don't have the patience, we don't have the advantage of time on our side to teach people what to do after they become employees. We can give them the resources for lifelong learning, but we expect people to hit the ground running, saying, I already know, as opposed to saying, I already know how to learn, teach me now.
Yeah, thank you, sir. I think that brings to the end of questions. This very, very useful, this interaction session, sir. I'll hand over back to the organizers.
Thank you.
Thank you so much, sir.
Very good evening to you. It's always a joy to listen from an expert who is a lifelong learner. I was amazed really to see that even in 2021, you have done a course from CMU. It's amazing, sir. It's a lesson to all of us that learning is not just one time, but it's a continuous learning. And so many lessons to carry from your talk. Firstly, your clarity of thought, preciseness, highly focused and context driven, and you are connecting to the audience so well. These are all the lessons that each and every teacher has to learn. And I feel this talk, especially it's very timely because Dayanand Sagar University is a very young and growing university, which wants to really make a difference in its teaching methodologies, curriculum, etc. It's very timely that we had your talk today. And the things that you touched upon, the duty of care, the responsibility of educators, it was really required at this stage of our university. And the hyphenated learning, I think CS is not just programming and hacking, but it involves many interdisciplinary domains which CS engineer has to be aware of. We were extremely impressed by the hyphenated sciences, sir. And we were always, hearing about additive engineering, and the subtractive engineering was something new that has been existing for a long time. So even at your lecture started at 9 in the evening for you, and it's close to 10 o'clock at LA. And you were so fresh, and you were so excited about sharing your knowledge to us. Thank you so much, sir. And we wish we have many occasions to listen to you. Thank you so much.
Thank you.
Can I request our Vice Chancellor to making closing remarks, please?
Yeah. Good evening, Ashwin sir. Thank you very much. I think it's a very structured lecture. It had all the three components required for any university to consider. The first was with regard to the kind of technology that's of the future, where the students need to be educated so that they are going to be useful to the world in the future. The first part. Second part, you also indicated what are the courses which are very, very important for a student to master and at least get some hands-on experience. The second part, which is really, really fascinating. The third, you also gave a set of resources where the students can look for. I think if a student is going to follow your lecture in toto, I'm sure they'll be preparing for the future and face the world very, very confidently. And you also touched upon the kind of applications. I think the wide range of applications, the complex problems which were not even looked at in the past are becoming the easier for newer technologies to address. I'm sure the entire audience got benefited from this. And we sincerely request both from BITES and Dynamics of University, request you to give us one more opportunity to listen to you on a particular technology, because there are a lot that can be understood and can be realized. I think if you can find some time later, I know that you're very busy, and to accommodate this particular lecture, I really know how much of effort need to be put in on your side to reschedule and make this time available for us. We are extremely grateful to you, and also thank Arvind Srinivas for making this happen. And there are also your classmates who are in this lecture. Hiranyaya, Hiriyana Shankaraya was there, Gurdat Shanai, all of them attended this lecture. I think it's extremely nice of you to give this particular time for BITES, and we are highly grateful to you. And please consider one more opportunity to talk to our students at a later date. Thank you. Thank you very much.
Thank you. It'll be my pleasure at some time. We'll figure it out.
Yeah, sure, sir. Sure.
Thank you so much, sir. Thank you so much.
Thank you.
Good night.
All right. Bye-bye.
Thank you, sir.
Night.
Yes, sir. Bye.
Good night. Bye-bye.
Good night.